My name is Terry Ryan. I'm a developer advocate for Google Cloud Platform, and this is going to be Google Cloud Platform 101. My goal here, actually before I get started in goals and kind of explain stuff, I want to know a little bit more about you, who you guys are. So how many people here develop on a daily basis? All right. And how many people here do systems work on a daily basis? Okay. And how many people do both? Okay. Is it because you love DevOps? Hands? Is it because your bosses hate you and won't hire more people? Okay. Anybody here tell developers or systems people what to do? Like any managers in the room? Whoa, I should have checked that before I made a manager joke, shouldn't I? All right, well, luckily when you move to Google Cloud, you can kind of relieve your workers. That's good. All right, that kind of gives me a good idea of who you guys are and what's going on. Actually, I'm going to ask one more question. How many people are currently on Google Cloud Platform already? Okay. How many people have tried containers already? Great. How many people have tried some sort of serverless solution already? All right, great. Good mix. I'm really, really excited. All right, so what are my goals for this talk? My goals for this talk are to tour Google Cloud Platform from the perspective of someone moving their first app over to GCP. And that usually entails a particular set of processes, and it's challenging. Onboarding to a new system is always difficult. So I really feel passionate about this. I really like to help bring people onto the cloud easier. My secondary goal, which is not as important to me, is to explain all of the various things available in GCP. It's just too much. It would take too long. I'd be like an auctioneer. So instead, what I'm going to do is, as I go through and we migrate this app over, I'm going to point out certain touch points. Like it makes sense that we talk about storage and we talk about other computing things other than just virtual machines, although that's what I'll be focused on, virtual machines. So, okay, one other thing I want to announce is that we have an internal tool called Dory, which does question and answers during our big meetings. So when Sundar is answering questions in internal meetings at Google, he uses this tool we use to kind of surface our issues. It is available in the app. So if you go to the app and go to the session, you can actually do live, like basically ask questions while I'm speaking. I will go back after the talk. At the end of the talk, we'll have Q&A, and if your question does not get answered during the talk, I guarantee to you personally that I will go through and make sure they're all answered. So please, if you're interested, please participate in that, and we'll have live Q&A at the end. All right, so how do people move to the cloud? Most times when they try out a new cloud, they do pretty much the same thing. They pick up an app they have somewhere else, and they just try to move it to the cloud and see what happens, right? We call this a lift and shift. Just move the stuff, make it exactly the same as it was, just somewhere else. So I have a demo of a minimum viable app. I'm going to switch over to the demo laptop, and we'll drive. So this is a very minimal app. It basically is a tagging app for photos, right? So I have these photos here. I'm going to go through and add one just to show you this is a live system, right? I'm going to go through and say, okay. I'm going to upload. We're going to add some tags. I may have done this repeatedly to the point where my browser just gives me these options. I'll hit upload. It's there. It's all saved. All right? There it is. So we have a list of pictures. We have a list of tags that humans create to tag those pictures. Pretty easy, pretty straightforward, pretty simple. We're going to switch back to the presentation. All right. And let's just talk about the architecture. So I know none of you folks in this room have ever done, like, you put all your stuff on a single server and run your production app off a single server. Like, no one here does that. But we all know people that have done this, right? So this is what we're going to kind of use as a stand-in for, like, moving a real application. It's pretty simple. It's got application code. It's written in PHP. It's got a database to store all the tagging information. And it's got file storage in order to serve up the images. We're going to move it to this, where we have a single server that only runs the application code, and all of the stateful stuff is moved to a cloud-provided database and images, and then we'll kind of take it from there and go and do more things with it. So let's talk about our virtual machines, because that is really where this starts, right? You want to run this code on a virtual machine just on our network. So Compute Engine is the tool for running virtual machines on Google Cloud Platform. You can get 1 to 96 processors, 0.6 to 624 gigs of RAM. You can go 65 terabytes of persistent storage, 3 terabytes of attached SSD, and 208 gigs of RAM disk. Instead of kind of talking about all the features and stuff, we're going to build a VM right in front of you. So I'm going to switch to the laptop again. We're going to be doing that back and forth. And so this is Google Cloud Platform's console. I'm going to go ahead and create a new instance here. And you'll see here I can go, and let's give it a name so I remember. I remember to delete me. I'm going to delete it. And you see I can put it in any region I want that we have a data center. I'm going to choose Central because that is the one that is best for the demo. And I have a number of zones, right? So the first thing I do is I kind of start to make the shape of the machine. How many processors, how much memory is in it. But let's say I have a thing where 16 is too low, I'll be performance bound, and 32 would be overkill because I would be paying for stuff I don't need. I really need 24. One of the things you can do on our platform, which I really love, is you can just dial into exactly the number of cores you want, right? So I can say, I want 24 processors. That way, I'm not paying you for stuff I don't use, and I get the performance I need. I'm going to switch back, though, because I don't need that many processors. I can go and change my disk image. And you'll see that I have a whole bunch of flavors of OS: Ubuntu, Core OS, container optimized OS, Red Hat. All the way down here, Windows. Yes, you can run Windows on Google Cloud Platform. I'm going to stick with what I got because I like the defaults. Let's see, what else am I going to do? Let's see. When I go to Customize, something I didn't show you before is that if I want to, I can add GPUs. I can also set a minimum processor platform. So if I need the features of certain processors, I can get that on my VMs. I'm going to switch back to basic though. And then one of the last things I'm going to do is I'm going to allow HTTP traffic. I'm actually going to open up a firewall rule. This is the only firewall rule we have available like when you're creating, because it makes sense, right? It's HTTP. You always have to kind of you very often have to expose those. One other thing I want to show you here is that at the bottom, this is one of my favorite features of this. At the bottom, it says equivalent REST or command line. If I click on this, I actually get the command line commands to create this VM exactly as I've configured it here, but I can then take that, reuse it, dump it into my scripts, and build like a fleet of machines if I want to. So I can use this to sort of learn the CLI, which is really kind of helpful. And then one last thing. I love this. We have run in Cloud Shell. I'm going to show Cloud Shell because it's one of my favorite parts of GCP. I'm actually spinning up a VM that is only just like a command control center kind of VM. It has all the tools to run Google Cloud right there, and it's got a persistent home disk. So I can do things like, I don't know, gcloud compute instance list, right? And all the tools are there, and so I can basically use all of the tools to run Google Cloud Platform right on this Cloud Shell, which is great because now I can maintain and monitor my whole systems without having to get all this stuff on my laptop. For example, I was working on one of the demos. If you've been to the showcase, we all worked on them. It was really hard. One of the problems I had, though, was that I needed to build something in Python. And I don't have the right version of Python on my machine, and installing the right version of Python on my machine was evidently just more than I could do. But what was great was that Cloud Shell already has it all set up and already works, and so I was just able to pop over to Cloud Shell, get my work done, and do stuff without having to muck with my laptop, so it was great. So, okay, so I'm going to go and create this VM, and we like to say they take tens of seconds to start up. When I'm in a hotel room testing this before, it takes 10 seconds. When people are watching, it takes longer, and I don't know how it knows. So look away, look away. What do we got? All right, so delete me is going to be up in now. All right, so it's somewhere in the 10-second range. I'm gonna call that. So another great thing about the console is I'm going to go SSH into my machine. And I didn't pull down any certs, or at least not me manually. I didn't pull down any certs. I didn't have to hook up anything. Basically, it's available right within the browser. And again, this is great. I can SSH into these machines even if I'm not at my home workstation. Let's see. So just to show this is real, apt get update. Got to spell it right. And oh yeah, that's right. I always forget that you have to sudo it. So there we go. There we go. Bam. I probably pissed off half the people in the room with that pronunciation of sudo, right? Sorry. A little nerve-wracking up here. All right, so there we go. So we've gone through, we've created a machine. Let's now switch back to the live preso and talk about it. So creating a machine is relatively easy and straightforward. Here's gcloud is the tool you use to interact with most of Google Cloud Platform. gcloud compute instances create, and then you can create whatever you want. And the next thing is after I create a machine, I need to run commands on it. I need to install software. I need to configure things. So gcloud compute SSH, the name of the virtual machine, and then whatever command you've got. And then to get stuff from your machine to your VM, to get the code on it, you're going to want to run gcloud compute SCP, and then source and destination, just like you would with SCP normally. So these three commands, with these three commands, I can do everything I need, right? I can build a machine, I can install all the proper software I need on it, and then I can push my application code to it. Now, obviously, there are different ways you can do all this differently, but this just is bare bones. Like, the easiest way to get it done, we can do this. So, I don't like to talk about price, but I feel like with VMs and our technology, price is an important differentiator. So I want to talk about it a little bit. I promise I won't get too salesy. So one of the things that we do is when you start configuring machines, up in the right half side of the screen, you see an estimate, right? And as I add resources, right, I add more processors, the cost per month goes up. And it goes up, and I'll go, I went crazy, right? Because Google pays for these, right? When I spin them up, so I like to make them big. And you'll see I've got a charge. Now, when we break down the charge, one of the things that we do, and it's really important to know, is that we have a base charge if you're just running your machine kind of haphazardly. But if you run your machine for a consistent period of time, up to a month, we will, a month being 100% of the time you need to run, and then the next month you get another sustained use discount. We will knock a significant portion off the price because we appreciate having consistent load size. We appreciate being able to plan better because you have a set size that you're going to keep running in perpetuity. Now, this is great. Sustainable use discount is great, and like for things you want running all the time, it's really good. But there's another option I should talk about, which is called preemptible VMs, and you'll notice that's significantly less. But there's a catch, right? Because there's got to be a catch. The catch is that a preemptible VM, which is what you have to flip a little setting and it becomes preemptible. Preemptible VMs will disappear sometime in the next 24 hours, and they're guaranteed to go away in 24 hours. But they can go away anytime. So like I have literally started up a preemptible VM and then went to SSH into it, and it's gone, and I was completely confused. So why would you want these? Well, a lot of times we have work that we need to do kind of whenever it gets done, batch work, big data jobs. Well, you can push those jobs as long as you have some sort of queue set up that is can be tolerant of a machine going down. You can do them for 1/5 the cost of the normal way of doing that operation, as long as soon as the queue is as soon as the machine goes down, the queue holds. You can always request another machine. There's nothing stopping you from requesting another preemptible machine, and then boom, you're going through your queue at a pretty good rate and doing it at 1/5 the cost. Or you could just spin up 5 times the number of machines and get it done in 1/5 the time, I think. My math is a little bit hokey there. All right, so I talked about disk images. We provide disk images, but you can create your own. Typically what I do is start with one of our images, modify, customize, make it unique to what I want, and then freeze it. And then I can create new machines from that, which is really helpful. But I could also make them from scratch using VirtualBox in a process that I have never done, so good luck. But it can be done. IP addresses, you can get private and public IP addresses. You can definitely turn off public IP addresses. You can also get static or ephemeral. One of the cool things I like is when you get an ephemeral IP address from us, if something happens and someone shares that ephemeral IP address, and now that's the permanent IP address of the install, and you're like, but this could go away anytime, you can make any one of our ephemeral IP addresses just static. You can just say, give me that, and that's mine now, which is great. Or you can just have a static one. Now, they don't cost you anything unless you take a static one and then park on it, because we're all trying to avoid the IP4 apocalypse, right? So we want to make sure that if you have addresses, you're using them. Firewall, kind of briefly talked about that. You create a rule, open open port 3306 on TCP. And then you give that rule a tag, a name. So that would be MySQL for those who are playing along at home. And then you tag machines with those rules, and that's how you open up the firewall. I want to take a slight detour and talk about Cloud Shell. I really love Cloud Shell. It's a great developer tool. It's a really great way of not having to have this stuff on your machine all the time. I didn't show it, but there's actually a code editor that you can use, so you can actually edit code on the fly in kind of reasonable syntax highlighting and everything. Really helpful when you're in a pinch, when people are calling you and you are not near your computer or your own personal computer. All right, we're back. There's one last consideration I want to talk about, talking about our VMs and our network and our setup. When you create one of our VMs on our network, you don't have to do any setup to make one data center talk to another. By default, in one project, all your machines talk to one another, and they use our really, really high-powered back-end network to do that. And so instead of having to go to like a different zone and find like, oh, this data center has these machines, and then this data has, they're all in one project. And so this means you can do kind of crazy fun things, especially with our network. So I'm going to switch over to a demo, and I'm going to take a selfie, if that's okay. I'm going to take a selfie with all of you. I hope that's okay. If it's not, we'll blur out faces eventually. That's okay. No one's. All right. So here we are. Right. We're gonna. Here we are. Da-da, and boom. Yeah. All right. Over there. And so we're using. This was the test, right? I am clearly not pleased with any of you. No. I'll upload this and I'll refresh. Oh, come on. Oh, I didn't upload. You actually have to upload, like you have to press the button. So here we go. We're uploading. There we go. There we go. All right. You know what? I'm going to roll with it. So what I'm going to do is I'm going to take this picture, and you'll see that I have this map. I have machines in all of these data centers. And I set them up really easy, just with a script, just like I showed you. And what I'm going to do is I'm going to take this picture and bounce it around our network. And every time it hits a different point on the network, we're going to stamp it as if it had like a little passport stamp, right? And you can see it happening in live, real time. We're actually traveling. So we went from Taiwan to Tokyo to Sydney to Oregon to Iowa to Virginia to London to Frankfurt to Sao Paulo faster than I could say it out loud. We did it in 4.4 seconds with 600 milliseconds or so of processing. What's great about this is I didn't have to do anything with the network to get this to work. It just worked out of the box. And that's something that I really like. Having tried other providers, like I get spoiled with this, like not having to do a tremendous amount of work, which I shouldn't really say that I'm happy with that. My boss is in the room, but it's okay. I do like working. I don't like wiring up networking. With that, I'm going to switch to the Prezzo. And we're going to move on to the next topic, which is storage. Where do I put my stuff? So at the file storage level, we have two products, one which was we announced recently, and cloud storage. I'm going to talk through both of those options, kind of talk why you choose one over the other. So cloud storage is bucket-based storage. We didn't, everybody does bucket-based storage, right? It's kind of a common metaphor. We didn't steal it from anybody. With one set of interfaces, even though I have all these different types that I'm going to talk about, every time you deal with them, whether you're going through the console or you're going through CLI tools or SDKs, it's the same commands, just with different types of storage. What are those different types? Well, we'll start with multi-regional, which is globally available storage. This is for stuff that you want to push out as close to your users as possible, right? You want it to be for web content or videos or mobile stuff, right? You want it to be that when your users go to get it, it is as close to them as possible. As opposed to regional, where what you really are trying to do is you're trying to keep it as close to the processing as possible, right? Like this is big data jobs, or maybe you need to stay in certain regions of the world, data can't leave it, or other reasons, right? But here, the data is only in one region and is close to the machines you're using to process it. Now, this doesn't mean that you can't open up regional data to the rest of the world. Like you can't, like someone in California can request something in the European data center. No, you totally can. It's just the latency is going to be a little bit longer because it's not duplicated as close to the user as possible. Then we have two other options, nearline and coldline. Both are longer-term storage options. Nearline are for backups and long-tail media, right? There's stuff that you you occasionally get to, and it's planned that you'd have regular access to it, but it's not something that you're getting every day. And then ColdLine, I like to kind of say, when you're downloading stuff in ColdLine, from ColdLine, in one browser window, you have your resume open in another, right? Because it's for compliance and disaster recovery stuff that you hope you never have to pull. So you want to store that, right? Because you have to store it, but you want to store it as cheaply as possible and never, ever use it. So that's what ColdLine is for. This is kind of the general cost for in the US, and they're different in different regions, but the deltas are always pretty much the same. Multi-regional is 2.6 cents per gigabyte per month. Regional is 2 cents per gigabyte per month. Nearline is 1 cent per gigabyte per month. And then ColdLine is the cheapest at 0.7 cents per gigabyte per month. There's also another cost involved, which is retrieval. So if I go and retrieve a file from multi-regional, regional, we don't charge you for just accessing the file. Whereas with Nearline and ColdLine, because we want to encourage you to kind of park them and leave them, we have a 1 cent per gigabyte charge for pulling down from Nearline and a 5 cent per gigabyte charge for pulling down from ColdLine. And again, that's probably the least of your problems then, but just know. All right, we have another option which is called Cloud File Store, which we again released recently. It's basically managed NFS, and it's a shared file system. You get really low latency because you connect it to the machines you're actually using, usually in the same data center. There are two service tiers, a premium and a standard. It's basically it's NFS. It's NFS that we manage. So what should we use? Well, NFS is attractive, especially if I'm using it somewhere inside, but the fact of the matter is I want to share this data with the world. I don't want to do a lot of work to do that. If I do NFS, then I have to put some sort of system to share on top of it, and I have to manage that with cloud storage, as you'll see in a second. It just shares immediately, and it's pretty easy. So I'm going to use cloud storage. So let me give you a quick demo of cloud storage. I'm going to switch to the laptop again. And here we go. I'm on the laptop. Great. I'm going to go ahead and create a bucket. I'm going to call it Tagger 102. I'm just going to create a default one, and you'll see that's it. That's all I had to do. It's already created. I'm actually going to upload files already. So let's just upload all the files from our app. You'll see that they push up. They're going fast. Fantastic. Now they're in cloud storage. And one of the things I love about this is, right, so let's see, Cloud Storage Gladiator. I'm going to share it publicly. And when I do that, I click public link, boom, public. That's how fast. It's already there. You see I've got a URL for it. Now, one of the other files is ewalk. I'm going to pick because it's short. And I'm going to do a little URL walk in here. Ooh, no, I did not mean that pun, and it came out. Oh, no, it's terrible. And you'll see that I can URL walk, and I don't get it because those types of permission sharing happen that fast. So cloud storage is just sort of drop dead easy. It just, boom, works. So with that, I'm going to switch back to presentation. All right. So to get stuff to cloud storage, I can do it via command line using gsutil, which is equivalent to gcloud, but for file storage operations. I can share publicly by using gsutil im to do those operations. Now, one thing I'll point out is that I shared one file within a private bucket. I don't recommend doing that because that's when bad things happen, right? That's when human error will take over and you'll accidentally share something you don't want to. So what I like to do is I have public buckets and private buckets, and I don't mix the two. But your mileage may vary. Do what you will, but that's my advice. So my app needs to talk to these things, and to talk to the app, I need to use our client libraries. In our client libraries, you see here are the languages that are listed. We also have REST APIs that are reasonably well documented if you need to do it from another language. But I'm going to use PHP because that's what I use to write this app. I want to get done fast. Well, when you use PHP to move files that have been uploaded, you use move uploaded file because it's right on the nose. That's the system command to do it. And you see I take a source and destination. Now, to do this in using the SDK, I need to do a little bit more code. Right? I need to use the right library. I need to create a storage client, create a storage bucket reference, and then upload the file. But not a tremendous amount of more work in order to accomplish the same thing. So basically, I just swap that in, and then our app is looking like this now. I've moved all of the images to a cloud-based solution. The application code is still living on the same machine as the database, and we should fix that. So let's go to the next and talk about application storage. Clearly, we get the whole SQL versus NoSQL conundrum. Oh, my phone is going off because I am in dumb. So SQL versus NoSQL, you get into this conundrum, and I don't clearly have a winner, although I do hate one of them, but I won't tell you which. But both of them are valid, both of them do things. So let's talk about SQL first. So Cloud SQL is our tool for SQL. It is a traditional SQL server. It is vertically scalable. We provide managed backups and easy to set up replicas, and we make it easy to do high availability. Vertically scalable means you can only get it so big, and then if you need more resources, you need a more powerful machine, you have to come up with some other solution. We also have something called Cloud Spanner, right, which is for structured data. It's SQL. It's both highly available and strongly consistent. Now, those of you that know CAP theorem may say that's kind of impossible in CAP theorem databases. Like, what are you doing here? So what we did is we found the guy who wrote the CAP theorem. We hired him, made him a VP, and he's kind of like, you can say it. Which is sort of close to the truth. Basically, there are reasons why we can say that. There's a big white paper. You can read it. It is both of these things, and it is amazing. It's globally distributed and horizontally scalable, which means you can keep adding stuff. If you need resources in another place, you can add them in another place. It's important to note that this is cost-effective at scale. For this app, it would be like massive overkill, and my boss would fire me because my bills would be much higher than the real value of Tagger, the app, right? So make sure that it's cost-effective for you to use it. But if you have that type of scale, it is amazing. Talk about our NoSQL option. The two main ones that I like, that I use a lot, and I would use in this sort of application is Cloud Data Store or Cloud Firestore. Both are document-based, both are indexable, and it's hard to tell sometimes the difference between the two, like when would you use one versus another. So I'll make it real easy. If you're doing stuff server-side, you probably want to use Cloud Data Store, right? You're talking from Google Cloud somewhere else on Google Cloud. You want that to be Cloud Data Store. If, on the other hand, you're doing a lot with client work, you're doing a lot where you want to bypass the server completely and just have data stored directly from the client onto a data store, Cloud Firestore is right for you. Cloud Firestore is sort of a marriage of some of our Cloud Data Store technology and the expertise of the Firebase team. And so because of that, it has a great web and mobile SDK and really works well with those environments. Okay, so which one should we use? Well, I'm not switching to NoSQL because it was written in SQL, and I'm not switching to NoSQL. That would be like much more than I'd want to do for an experiment like this. Cloud Spanner is really overkill, and so what I'm going to do is use Cloud SQL. So let me drive Cloud SQL a little bit for you. Here's our SQL machine. I'm going to go ahead and create an instance. You'll see it gives me a choice between MySQL and Postgres. I'm going to choose MySQL. You'll see here it gives me some kind of pre-configured options to make stuff easier. I'm going to go with a development server and then like mess it up. So let me do that. I'm going to call this Tagger. Let's see. And then here's where I can have some fun. I can configure the type of machine and storage. So I'm going to start. Right now, the initial one is micro. And you'll notice over here that I have a performance kind of meter, how performant this machine is going to be. I'm going to go ahead and change the processor. And when I change the processor, you'll see that I maxed out network throughput. So if you want more network throughput, add more processors to your SQL boxes on Cloud SQL. If I want better IOPS, well, I can just, hold on. You'll see here that as I increase the number of IOPS, the disk throughput and IOPS and all that goes up. And as I add more, eventually I max it out. So if you need higher performance out of your SQL servers on Cloud SQL, that's the way to do it. And then I can also enable automatic storage increases, which is great. Like if I'm getting close to my disk, instead of having to have a big, instead of, not that being here is a problem, but if I'm worried about that, I can just enable it so that it'll grow as my data set grows. So okay, I am going to cancel out of that, and then I'm going to switch back to presenting. All right. All right, so how do I get my data into Cloud SQL? Well, I do a database dump, right? Like I do my SQL dump, and then I do gsutil and copy it to cloud storage of all places. Once it's in cloud storage, I run SQL import SQL to import that file. And then after I import the file, because you shouldn't leave your SQL dumps lying around in a place that can be made public, you delete the file. Now, slight detour. This pattern of pushing stuff to cloud storage and then pulling it down elsewhere in Google Cloud Platform is kind of common. And I kind of see cloud storage as sort of a hub between a lot of different technologies. You see this, you have an application running cloud functions, you put a picture in cloud storage, and then manipulate it with Vision API or something else. This pattern of being a hub also applies to Cloud Pub Sub, which I'm not really going to show off because it doesn't make sense for this app. But Cloud Pub Sub does what for messages what Cloud Storage does for files. It basically acts as a conduit in between all. So it is a messaging bus that does the publisher-subscriber model. You have many publishers or one publisher, many subscribers or one, and then it'll make sure that all the subscribers get all the messages from all the publishers. Okay? I'll come back to that. All right. Now, some common problems with doing Cloud SQL. First one is you do gcloud SQL, and you import a file, and you get an error. Right? And this is internal error. Okay. I didn't think it'd be an external error, but fine. All right, internal error. And then you dig into it, and you set up a verbose mode, and it'll tell you, guys, this was a MySQL error, which is really not that much more helpful. And I have a bug filed. I'm not bitter that they haven't fixed it. But how do you figure out this problem? So in the Cloud Console, there's this thing called Operations, a tab called Operations. At the top, you'll see that I have an error, and it even includes a line number. So I can track this down and maybe see what it is. Turns out that MySQL dump, if you had super privileges locally, and you might have because you're experimenting with stuff and you accidentally up them, like I totally did in this case, you can't do that because we don't allow super privileges on the box. So watch out for that. All right. So what if you need something we don't offer, right? Like I talked about Cloud SQL, I talked about our products, but maybe you need Redis, or maybe you need I don't know, Mongo or Cassandra or something. Well, there's two options. You could always build it by hand using Compute Engine, right? Because it's just a VM. You can install stuff on it. We also have a thing called Cloud Marketplace, which just recently was renamed. If you're familiar with the platform, it's called Cloud Launcher. It's now Cloud Marketplace. And there are pre-built solutions for things like Cassandra, Redis, Mongo, CouchDB, and more. Now, it's important to note that we will not manage these for you, right? We build them. We one-click build these things, but then managing them is on you. It won't be the way our SQL boxes are. All right, so here we are, right? We got our app from a web application on a single server, and now we're running all our state elsewhere, and we have all our code on a single server. This opens up a whole lot of possibilities for us, right? Because this is sort of the modern, the 12-factor app, at least part of it. We have application code running one place, and we don't have to store state anywhere. And so we can start mucking around with what we're doing on this single server. So let's talk about some of our computing options. What do we use to build this stuff? So how do we scale this system? Now, there are a couple different ways of scaling this system. What happens if Tagger becomes a breakout success? It won't happen, I know. It's fine. It won't happen. But what if it does? Well, there are a couple ways of dealing with this. The first way would be to use a completely Compute Engine solution, which is a combination of using a managed instance group and a network load balancer. So a managed instance group, which I'll talk about a little bit more in a second, is basically a collection of VMs that perform the same role and can be pointed at one load balancer. And then our load balancers are load balancers, which are pretty straightforward. You don't kind of know what they are. So talk a little bit about them. Our instance groups, we could say that they're managed or unmanaged. I chose managed for that because one of the cool things about a managed instance group is you can say things like, all right, because all the machines are exactly the same, you create a template and it'll create the same machine over and over again. You can say, I want processor utilization to be at 60. If it goes above 60, spin up another box. And because you have a template, it can spin up another box and it's perfect, and it perfectly kind of fits what you're doing. You can also do unmanaged where you can build your own machines and add them to it, but then they could be different profiles of processor and memory and that sort of thing, so we can't really auto-scale or auto-heal them. So that's how you make a collection of VMs that all do the same task. You throw a load balancer on top of them, right? And we have the interface will show you three different options. We'll show you HTTP, TCP, and UDP, and you can make any one of them local. internal only, so it doesn't get exposed to the public internet. So HTTP is our equivalent of a L7. Load balancer TCP UDP is the equivalent of a L4, and then all of them can be made internal only. So we're at a cloud conference, and I have not said Docker, I have not said container, and I have not said serverless. Like, what's going on, right? I also haven't said AI, or big data, right? But I'm going to focus on container and serverless. These are two terms that you typically want to maybe consider moving your container, your computing load to. So what are containers? For those of you who might not be familiar, containers basically consist of two things. And this is, if there are container experts in the room, I'm sorry. I really oversimplified it, but I wanted to make it really simple for people who are not familiar with it. So containers are made up of two parts. One, a package file containing all of the code and runtime components it takes to process your app or your microservice or whatever you're running. And then you have an environment that tricks that package into thinking it's the only machine that's running, it's the only system running on that machine. Now, this is in contrast to a VM where like you carve off bits of the machine and say use 16 megs of memory, and if it only uses 8, well, then that extra memory is gone. You can't kind of pull it back because it's been carved off. So doing it this way, these containers are all kind of tricked into using the same kernel. Maybe they're not tricked. Maybe they're just induced and encouraged or something. But what that allows them to do is spin up very, very fast because we don't have a whole operating system to tear up and tear down. And we can fit a lot more of them because unlike a VM where you allocate blocks of resource, these are just processes, and they use exactly as much memory and resources as they need, and then the rest is still free for other containers to pick up and use. So there are two container solutions that I like to talk about at Google Cloud Platform. You obviously can spin up Docker on a VM, and like there's nothing wrong with that, and we actually make it relatively easy to do. But the two container solutions I like to talk about are Kubernetes Engine, which is managed Kubernetes. Anybody here familiar with Kubernetes? Okay, yeah, that's intimidating. So good, you all know what Kubernetes is. For those of you that don't know, Kubernetes is a container orchestration system. When you have one container, it's pretty easy to kind of keep track of. When you start having 20, 30 containers that are all part of different systems that all need to be wired up to different networking solutions, it becomes challenging to keep track of them all, and so Kubernetes manages that for you. That's really oversimplification. Now, Kubernetes itself is a very large bit of software to manage. Kubernetes Engine is probably the easiest way to run it because we'll take care of like building all the machines for you and setting up smart defaults for monitoring, logging, DNS, service discovery, and auto scaling. We also have this thing called App Engine Flexible, which is much more simple. You basically create a custom runtime Docker image. It's got to serve up on port 8080, and once you do that, we will scale it to as little or as much as you need, starting at 1. So we'll leave it running all the time. You have one container, one service that's running, and one endpoint. And if you get a lot of traffic, we'll just scale it out. And if you get less traffic, we'll scale it down. Much more simple, but it's better when you have just a very simple thing. It's a quick and easy fix for a lot of this stuff. All right, so what is serverless? All right, serverless is a marketing term, right? We all know it. We're all in technology. We all know it's a marketing term because we know there's not some sort of weird octopus creature that these things are running on. It's a server, right? There's a server somewhere, and we know that serverless is a lie. But it describes something for you, the user, the person consuming the service. The server has disappeared, right? Because you don't interact with it. You don't ever have to worry about like setting it up or like did I provision enough or does it have enough memory? Like we take care of that for you. So serverless describes a service where you pay as you go for only what you use, and you don't have to be aware the system's running on it. And that is actually a really cool thing, even if it is a marketing term. All right, so serverless. We have two products that I kind of call the serverless products at Google Cloud Platform. One is Cloud Functions, which is function-based. You write a function, send mail, right? You have one function, sends email, right? You then attach them to events. So someone writes a file to cloud storage. You can attach a cloud function to that and send mail. You can attach that event to a pub/sub message. You can attach that event to a URL call, so you can actually make URL calls based on Cloud Functions. Now, if you need more than just one function, right, you need to chain a whole bunch of environment stuff together and create a full application, well, App Engine Standard is probably the way to go there, right? We have a number of runtimes for App Engine Standard, which we announced today that we are releasing some new ones in the near future, which is really exciting. But basically, you have to write in these languages in order to use App Engine Standard. And there's some restrictions, like if your software is based on like a C executable that you wrote 10 years ago, you can't pull that into App Engine and have App Engine scale it. But if you keep with those constrained capabilities and you just write code in these runtime languages, we will incredibly rapidly scale your application. I have a demo, I'm not going to show it, where I take an App Engine app that is cold, that hasn't been hit in a day, and I scale it from 0 to 8,500 queries per second in less than 5 minutes. So 8,500 QPS is pretty high, but what does it really mean? 8,500 QPS is about 30 million requests an hour, or what Wikipedia does on an average hour. So on App Engine, you can scale from nothing to a Wikipedia level traffic site in less than 5 minutes, which is really cool and fun. So the question is like, so this tagger service, this thing, should I switch this over to one of those? And my answer is, well, it depends, right? Typical weasel IT answer. It depends because if probably not, right? Like it's just a simple app that I'm running. It's probably like a legacy app that I've rolled over and I need to keep going. I don't know that I would move it off a VM. It's running fine. Just leave it on a VM. But if, like, let's say I want growth in this app. Let's say I want it to go bigger and better. Then maybe I would push it to containers, right, and have it run with a whole bunch of other similar services, so I get the most resources out of my hardware that the virtual hardware that I'm pulling down. Also, if I have this app that's not very frequently used, running a VM all the time may also be something that would be too much of a cost. So I might switch it over to serverless and take advantage of the fact that serverless you only pay for what it's used. It would depend on how much it's used. So my answer is depends, but for this app, I don't see it lighting up anytime in the future, so I would probably leave it on the VM. So, conclusions. One, so we started here. I just kind of recap what we did. We had a single server app. We moved it over to this sort of configuration, single server, which opened up a whole bunch of possibilities to us of maybe switching to containers, of maybe switching to serverless. And we left our images and our data elsewhere, which was great. We did this with Compute Engine. On the single server side. We did it with Cloud SQL on the database side and cloud storage on the image side. Now, I switched to those hexagons because one of the things that we do is we kind of showcase all of our products. And I want to talk about just how much we didn't talk about. So we talked about a lot of the compute stuff, which is great. I'm happy. We talked about a number of the storage and database options. We talked about networking, and we talked about big data, the Cloud PubSub reference. Cloud Vision API, I cut a demo, so we didn't talk about that at all. We talked about Cloud SDK, we talked about some of the management tools, but the entirety of Cloud Platform is much bigger. There's a lot more stuff there. I hope that as you look through this sort of display of our stuff, that you see places where you want to go. I hope that I kind of showed you some of it, but we can see that there's a lot more, and if only there was some place that you could go to which would provide you with answers about the rest of the platform. Like, I don't know, like some sort of conference. It would be great if you could answer some of these questions about what these things do elsewhere.